In the quiet hum of the cosmos, where stars are born and die in silent majesty, one name from antiquity resonates with a brilliance that rivals the celestial bodies he so meticulously studied: Hipparchus of Nicaea. Long before the age of telescopes and space probes, this remarkable Greek astronomer, geographer, and mathematician laid the very foundations of how we perceive the heavens. His work, a tapestry woven from observation, mathematics, and sheer intellectual prowess, has guided humanity's gaze upward for over 2 millennia. Today we journey back in time, not just to recount history, but to understand the mind of a man who, with the simplest of tools, managed to map the stars and measure the universe in ways that were nothing short of revolutionary. This is the story of Hipparchus, the architect of the stars, and his enduring cosmic legacy. Born around 190 BC in what is now modern-day Turkey, Hipparchus lived during a golden age of Hellenistic science. While many of his original writings have been lost to the sands of time, his monumental contributions survive through the works of later scholars, most notably Ptolemy in his Almagest. It is through these secondary accounts that we can piece together the portrait of a genius. Hipparchus wasn't just an observer. He was a systematizer. He sought to replace descriptive, qualitative astronomy with a predictive mathematical science. He believed that the universe, for all its vastness, operated on principles that could be understood, calculated, and forecasted. This philosophical shift was his first, and perhaps most profound, gift to science. One of his most significant achievements was the creation of the first known comprehensive star catalog. Imagine the patience and dedication required. Night after night, using rudimentary instruments like the armillary sphere and the dioptra, Hipparchus meticulously recorded the positions of at least 850 stars. He didn't just note their existence. He devised a coordinate system using ecliptic latitude and longitude to pinpoint their locations on the celestial sphere. This was a groundbreaking concept. For the first time, the starry sky was no longer a random scattering of lights, but an ordered, measurable map. This catalog became the definitive reference for astronomers for centuries, a celestial atlas that guided sailors across treacherous seas and helped scholars track the slow dance of the planets. But Hipparchus didn't stop at mapping. He also introduced a system to classify the brightness of stars, a system we still use in a modified form today. He ranked the stars on a magnitude scale from 1 to 6, with 1 being the brightest and 6 being the faintest visible to the naked eye. This seemingly simple idea was revolutionary. It quantified what was previously a subjective observation, allowing for a more precise and scientific comparison of stars. It is a testament to his insight that a magnitude difference of 5 on his scale corresponds roughly to a factor of 100 in actual brightness, a logarithmic relationship that our own eyes perceive naturally. He had, in essence, decoded the language of starlight. Perhaps his most celebrated discovery is the precession of the equinoxes. While comparing his own star measurements with those recorded by Babylonian and earlier Greek astronomers, Hipparchus noticed a subtle but systematic discrepancy. The positions of the stars relative to the equinoxes, the points where the sun's path crosses the celestial equator, had shifted over time. He concluded that the entire celestial sphere was slowly rotating, or wobbling, like a spinning top. He calculated this drift to be about 1 degree per century, a figure remarkably close to the modern value of 1 degree every 72 years. This discovery was profound. It revealed that the universe was not static, as many had believed. The fixed stars were not so fixed after all, and the Earth itself was subject to a grand cosmic motion that unfolds over millennia. Hipparchus's genius also extended to the movements of the sun and moon. He made incredibly accurate calculations of the length of the year and the month. His value for the tropical year, the time it takes the sun to return to the same position in the cycle of seasons, was off by only about 6 minutes. He also developed a sophisticated model for the moon's irregular orbit, accounting for its varying speed and path. This allowed him to predict lunar and solar eclipses with unprecedented accuracy. He understood that the moon's distance from Earth varied, which explained why some solar eclipses were total, while others were annular, where a ring of the sun remains visible. He was applying rigorous geometry to celestial mechanics, transforming myth and mystery into predictable science. To achieve all this, Hipparchus needed a powerful mathematical tool. And when one didn't exist, he invented it. He is widely regarded as the father of trigonometry. He created the first ever trigonometric table, a table of chords, which was the ancient equivalent of our modern sine function. This table allowed him to solve any triangle, a fundamental requirement for converting observational angles into distances and positions in space. With his table of chords, the cosmos became a geometric problem to be solved. He could calculate distances to the moon and sun, estimate their sizes, and model their orbits with a mathematical rigor that was unheard of. His development of trigonometry was not just an academic exercise. It was the engine that powered his entire astronomical system. Let's pause to truly appreciate this. In an era without computers, without even the concept of zero in his part of the world, Hipparchus was performing calculations that would challenge many today. He was processing vast amounts of observational data, spotting subtle patterns, and developing new mathematical frameworks to explain them. His work represents a monumental leap in human understanding. He demonstrated that through careful observation and logical reasoning, humanity could begin to unravel the deepest secrets of the universe. He established the scientific method in astronomy: observe, measure, hypothesize, and predict. His influence cascaded through history. Ptolemy built his entire geocentric model of the universe, the dominant cosmological system, for over 1,400 years, directly upon the foundations laid by Hipparchus. While we now know the Earth is not the center of the universe, Ptolemy's system, thanks to Hipparchus's data and methods, was incredibly effective at predicting planetary positions. When Copernicus, centuries later, proposed his heliocentric model, he too relied on the observational tradition and mathematical techniques that originated with Hipparchus. In this sense, Hipparchus is a pivotal figure, a bridge between the ancient world and the scientific revolution. So why is his name not as famous as Ptolemy, Copernicus, or Galileo? Perhaps because so much of his work was absorbed into the writings of others, his individual identity became overshadowed. Or perhaps because his focus was so relentlessly scientific, lacking the grand, philosophical pronouncements of others. He was a craftsman of the cosmos, a meticulous architect, more concerned with the soundness of his structure than with its public reception. But today, we can look back and see his legacy clearly etched across the stars. Every time an astronomer measures the brightness of a star using the magnitude scale, they are using a system born in the mind of Hipparchus. Every time we account for the precession of the equinoxes in our celestial coordinates, we are acknowledging his great discovery. His spirit lives on in the precise calculations of spacecraft trajectories and in the digital star charts on our phones. He taught us that the sky was not a realm of gods and myths, but a physical space governed by knowable laws. He gave us the tools to map it, the language to describe it, and the confidence to question it. In the grand narrative of our quest for knowledge, Hipparchus of Nicaea is not just a footnote. He is a foundational chapter, the first true star mapper, the man who laid down the coordinates for our journey to the cosmos. Thank you for joining us on this journey through ancient skies. If you found the story of Hipparchus as inspiring as we do, please like this video and subscribe for more explorations into the history of science. Until next time, keep looking up.